Hello, my name is Sarah Matthews, and for my demonstration, I'm going to be speaking about atherosclerosis and arteriosclerosis. Through my demonstration, I will be talking about their processes and also how exercise positively affects the symptom severity of these two diseases. So arteriosclerosis is the number one cause of cardiovascular disease, pulmonary artery disease, and stroke. So arteriosclerosis is really just the umbrella term, and atherosclerosis is just a type of arteriosclerosis. So our first term, arteriosclerosis, is the hardening of the vessel wall. And the hardening of the vessel wall will not be good for our heart because it decreases blood supply. So when the artery becomes hard, it will lose its elasticity, which reduces the amount of blood flow. And atherosclerosis is the plaque buildup in the arteries. So when the plaque builds up, it protrudes the vessel wall, which ends up decreasing blood flow. And most of the time, people with chronic diseases do have both of these at the same exact time. For the pathology of these diseases, we start with a good, healthy vein, good blood flow. The blood viscosity just allows blood to flow through. The elasticity of the wall just pushes blood through. You have great blood flow. And then what happens is the artery wall becomes damaged. The endothelium cells right here, they become damaged. And what damages the wall is the cholesterol, the fats, the cellular waste. It just flows through the vein, scraping off the sides of the wall. And once it scrapes off enough of the wall, they become trapped in the wall. So right now we have cellular waste, cholesterol, and fat just starting to build up in the wall of your artery. Once the cholesterol and all the molecules get trapped in the side of the wall, and this right here, this is a picture of the side of the wall. So the cholesterol molecules are trapped inside the wall. They keep growing, and the cholesterol molecules will actually oxidize. And when they oxidize, they will cause an inflammatory response. This inflammatory response will cause the endothelium cells to call for help. And once they call for help, monocyte cells will come to the site, and these monocyte cells will turn into macrophages. And the macrophages will end up eating all of the cholesterol. And when they're eating the cholesterol, they're getting a lot bigger. And once they get big enough, they turn into plaque. So then you have plaque forming in all of the walls of the arteries. Now I'm looking at the artery at like a bird's eye view. So right here we have the wall, and then right here we have the inside of the cell. So once those macrophages begin to eat all the cholesterol, they build and they get bigger, forming plaque. This plaque will eventually protrude into the cell, blocking blood supply, blocking blood flow. So once we have the plaque buildup, we also will begin to see that smooth muscle along the inside wall will begin to slide through the plaque, and come to the outer surface of the plaque. So this is causing an even more protrusion of the vessel wall. And then right here, we see that this is blocking even more blood supply than when it was just plaque. So after the smooth muscle comes to the surface of the plaque, it will be such a big protrusion in the side of the artery wall that it will actually bust. And this is called a lesion. So when it busts, the plaque will be able to escape from the side of the wall and enter the bloodstream. So when the plaque is in the bloodstream, it's flowing through, and as you can see, there's going to be so many other plaque buildups along the artery wall. So as the plaque is going through, it'll get stuck by one of these protrusions, and as it gets stuck, it will block all blood flow, which will cause a blood clot, and then that will end up causing an MI, a myocardial infarction. I also did some research on clinical studies about atherosclerosis. I did this to compare recent research versus like the original research that what most people go on. I found that most people believe that HDL directly prevents atherosclerosis, and this is due to HDL decreasing the amount of bad cholesterol, LDL. But the study that I found stated that HDL indirectly affects atherosclerosis. It was stating that HDL, it depends where HDL is secreted from. So it said it was comparing the liver versus the intestines. So if the HDL was secreted from the liver, that directly affected the liver and also vessel walls, which was the intestines had a completely different function. So I think that these two clinical studies, they can be contrasted just to see that HDL it has an effect on atherosclerosis, but it is not the main thing that really helps atherosclerosis and prevents it. Through class discussions and the research that I have done myself, and also my interactions, I have really I've realized how much exercise can affect everybody's daily lives, whether you have a chronic disease, you're healthy. Either way, exercise is the best bet because it's something that you can control, and that's just something that I had to realize. Like with physicians, you have to just rely on somebody else, but with exercise, you're having to rely on yourself. So exercise with atherosclerosis, it increases the HDL, which is your good cholesterol, and it also decreases LDL. And while it does decrease LDL, it also makes those LDL particles become bigger and less dense. So the article that I was reading about called them fluffy. So the LDL particles become fluffy and larger, and this will allow this will decrease protrusion in the artery wall. So when the particles are very dense, it's easier for them to just multiply, attach to other molecules, and just build a plaque, just build it, and then the protrusion in the artery, which blocks the whole artery. And in a study I found that leukocytes attach to macrophages. And during the study, they found that the leukocytes are actually decreased. So these leukocytes aren't attaching to these macrophages, causing a larger plaque, a larger protrusion. And exercise also will decrease macrophages in adipoid tissue. So that's just allowing the protrusion to be decreased. And all in all, the exercise really just allows blood flow in the artery to be steady. It helps with blood viscosity, the blood elasticity of the artery, keeping the walls just very easily to pump, so the heart doesn't have to work as hard.